This is question number 2, the worksheet connected particles. Particles A and B of mass 0.2 kg and 0.3 kg respectively are connected by a light inextensible string. Okay, let's make the downward weight. So on A, there's a downward force of mg, which is going to be 2 newtons. And on B, there's going to be a downward force of weight, which is going to be mg, which will be 3 newtons. The string passes over a smooth pulley at the edge of a rough horizontal table. Particle A hangs freely and particle B is in contact with the table. So there's going to be a normal contact force here, R, vertically above the contact. There's going to be a tension away from the mass in this direction and tension away from the mass in this direction. And the string will have same tension at point A and B because it's one string. Okay. The system is in equilibrium, is in limiting equilibrium with the string taut and A about to move downwards. Okay, so the direction of motion for A is downwards. That means for B, it's going to be left. Limiting equilibrium means that it's not moving at the moment, and if a slight further force is applied, then it will move. Find the coefficient of friction between B and the table. Okay, so if B moves towards the left, there's going to be a frictional force in this direction, friction, which is equals to mu R. And we have to find the value of mu R. Okay, now since the system is in equilibrium at A, T is going to be equals to 2 Newton. And similarly at B, T is going to be equals to the friction. T is already 2. And mu is what we have to find, and R is opposite to 3, so it's equals to 3. So mu is equals to 2 over 3 is the value of coefficient of friction. A force now acts on particle B. This force has a vertical component 2.8, 1.8, so there's a component in this direction, and a horizontal component of x Newton directed away from the pulley. So now there's an x Newton force in this direction. The system is now in limiting equilibrium. That means still it's at rest with the string taut and A about to move upwards. Okay, so now the direction of motion changes. This will go upwards and hence this will go towards the right. And because of that, the friction will act towards the left. Friction or mu R will act towards the left. Okay, so now we're going to find the value of x. So at x, x is equals to the tension in the string plus mu r. Okay. Now the tension is 2 from here again. And mu we know is 2 by r, sorry, 2 by 3. And r can be found by adding r in 1.8 and equating it to 3. So r is equals to r plus 1.8 equals to 3, which means r equals 1.2. So x equals, the tension was 2, mu is 2 by 3, and r is 1.2. So x comes out to be 2.8 newtons.